Hey guys, my name is Kamran Waziir, and in this video we're going to talk about how to make fluid simulation using Blender. So basically, first of all, we're going to learn the basic of fluid simulation. Then we're going to go for an example project, you can say, an example use of fluid simulation. So first of all, let's talk about basic of fluid simulation. In order to make fluid simulation, you need two things. So what are those? The first one is the emitter, which will actually emit fluid. And the other object is going to be a domain object. Well, what is domain object? You can say that anything that is inside the domain object will have fluid. Anything that is outside the domain object will not have fluid. So why do they introduce domain object? Well, if there was no domain object, then it will explode your PC. For example, you just have an emitter object with no domain object there, with no specific area. Then the Blender will start calculating the whole area, like you can see the whole thing here, which is impossible for a computer to calculate. So in order to solve this problem, they made a domain object, which actually act as a mask for, you can say, for fluid simulation. For example, I'm going to go ahead and click Shift A. I'm going to create a mesh, and it's going to be an icosphere. It's here, so I'm going to go ahead and turn on scaling tool, and I'm going to scale it down slightly. I'm going to move it upward just a bit. Okay, so this is going to be a flow object. You can name it flow. Enter. And now we need a domain object. Shift A, we're gonna go for a mesh, and it's going to be a cube. I'm gonna go to x-axis, and I'm gonna click S to scale it up, and I'm gonna move it by hitting G and Z to move it upward. So basically, you can just right click and go to set origin and set it to 3D cursor. So now we will be able to scale it from the cursor from the bottom on Z axis. So just hit S and then Z to scale it on Z axis like that. And if you go into wireframe mode, you can see that this is going to be a flow object and this is going to be a domain object. So I'm going to name it domain. Enter. Okay. So basically, anything inside this area will have fluid properties. Not everything, but the one you assign fluid properties to it. And if you move the flow object outside the domain object, the fluid will not work. So you must have everything inside the domain object. After that, it's going to work. So basically, we face so many problems while making fluid simulation. It can also contain when you create an object, you create a domain object. But basically, you messed up the scale. Sometimes the flow object doesn't really emit any fluid. The reason behind that, you make it very smaller like that. And if it's very smaller, then you will not be able to emit fluid from it. So just keep it to something like that. And the other thing that I will talk about, if you want to start with simulation, just select both of the object and hit Ctrl A and apply the scale. It will help you make the simulation. And sometimes it really helps because it's just resetting the scale. Even though if your object is very big, if you hit Ctrl A, the scale becomes to 1, and that's really helpful. Okay. So now it's time to apply the properties into different objects. So first of all, we're going to select the flow object, come up to its physics property, and go ahead to fluid simulation. I'm going to go ahead and change the type to flow here because it's a flow object. Like you got three options: domain, flow, and effector. Well, the domain object is already added there. We will apply this to it later on. But right now, we're going to talk about flow. Okay, so what is effector? Well, in fact, if you want to have other object that will interact with the fluid, for example, you sit another cube here and you want the fluid to interact with it, to collide with it, then if you add this new object, you can apply effector into that object and it will have that property and it will interact with fluid. So right now I selected the icosphere, so I'm going to go ahead and apply the flow. Okay, so first of all, when the settings open up, it says smoke and geometry. Basically, Blender can create different simulation. It can be smoke, it can be fire, but the aim of this tutorial is fluid, so I'm going to change it to liquid. And we got a flow behavior here. So basically, if it's set to geometry, like for example, we got three options. So first of all, let's apply the domain property to that object, then we're going to discuss this. So I'm going to select the object, I'm going to go ahead and apply fluid. I'm going to set the properties to domain object, and it's set to gas. Let's change this to liquid also. Okay, so let's expand the timeline a bit so we can see what is going on. Right now, as you can see, the domain object is disappeared because we have added it as a domain object for liquid. If we play the simulation, we got something like this. It's like very basic, but we can improve it extremely. Okay, so right now, as you can see, only the shape of the icosphere falling down into the ground, nothing else. It's because if you select the icosphere here, it's set to geometry. When you set to geometry, it only creates the fluid equals to its geometry. It's not creating something like a flowing liquid, or you can say a tape that is flowing continuously. But if it's set to geometry, then it simply just creates the fluid equals to its geometry. It's not creating more fluid than its geometry. If we play it, simple. It's just very small amount of liquid. So if we change this geometry to inflow and we just go ahead and reset it and replay it, it will continuously flow and it will never end. It's like an endless sort of simulation. And the domain object is filling up with fluid continuously. Just pause it by hitting spacebar and reset it. We got the other object, which is outflow. If we just make it outflow, nothing's happened because this is not for this object. First of all, let's change it to inflow, and I'm going to create a new object. I'm going to click Shift A, and I'm going to go ahead and create a cylinder object. I'm going to go and move it towards here, and I'm going to move it upward a bit. I'm going to create a fluid also to that cylinder object, and I'm going to change the type to flow, but the flow behavior to outflow. So what it does, for example, if we play, now as you can see, this area is just empty. Let me just move it to the center, and let me just move it upward and fit it inside the domain object. Click S and Shift Z and scale it on X and Y axis. If we just play the simulation now, first of all, let's change the flow type to liquid because it was smoke. So I'm going to go ahead and redo it. So actually the inflow object, the outflow object is very simple. It's just removing fluid. Like for example, if you don't have this object here, and if you replay it, or for example, it doesn't have this property, I'm going to remove the, like for example, as you can see now, the fluid is not really flowing downward. If we just remove the fluid properties from it and replay it, now as you can see, the fluid is behaving the same as it was before. So basically let me just create it again, change it to liquid and change from geometry to outflow. Basically it removes any fluid which is colliding with it. That's simple. Okay, if I play it, nothing's really happened. Okay, so I think you got it because it's just a deleting object. So now for example, if you change the flow type to an effector, then the fluid is going to collide with this object, and if you replay it, as you can see now, it is interacting with this object, and I think it's really helpful. While if you have any character there or something similar to that, as you can see, it's perfectly interacting with this object, and this is what we wanted. So this is just a starting point of simulation because we just explained how the flow object works and how different properties. Right now we got different options. We got a mesh, and I just got a mesh here, a flow source, and you got a flow surface emission. If you increase, if you just stay on this property, you can see the instruction with it down there. So it says it's control the fluid emission from the mesh surface. Higher value result in emission further away from the mesh surface. So it's actually basically, for example, now the fluid is starting from the very center of, like from the surface of the flow object, but if you increase this value, it will start from a very far away distance. For example, I'm going to set it to 1.5 and I replay it. Now as you can see, the fluid start away from the surface of the flow object, which is actually in center there. But if I make it to 0 and hit enter, and let's try it again and see what we get here, and as you can see, we got the default value. Okay, so now we have initial velocity. It is in fact, it's just defining the direction of fluid. If you want to force fluid to move on x-axis, you can do it. Let's turn on initial velocity and change the x velocity to a positive 17 maybe meter per second, and let's play it. And as you can see, now the fluid is hitting the right side and it's moving on x-axis like that. So it's basically forcing fluid to move on a specific axis. For example, if I go for negative z-axis, positive z-axis, which is actually upward, the fluid will move first upward, then it will collide with the domain object. Let me just make the value a bit higher, something like 27. As you can see now, it's like colliding upward, but I think this value is useful for some cases, but not right now. I'm gonna reset it, and if you play it, it's behaving the same. Okay, so that was basically a flow object. Now it's time to explain the domain object here. So the domain object is here and it's selected. And first of all, we got domain types, which is actually gas and liquid. Basically, gas is used for smoke and fire. So for now, we're dealing with liquid, so I'm gonna set it to liquid. Then we got resolution here. Right now, it's like very low resolution simulation, and it's like really low poly. As you can see, everything can be seen like very low poly. If you set this to higher number, it will result in the highest quality possible fluid, but it will take time to bake, and it will also slow your computer. So basically, if I set it to 156 and I reset the frames, and now as you can see, my computer is already facing a huge problem. If I play it, it might get crashed because it's a huge resolution. And as you can see, it's calculated 7 frame and it's still working on it. I'm gonna pause it right now. This is like if you want to go for like a final sort of resolution, then I will suggest 256. But right now, for just a preview, I'm gonna set it to 75. Oh, it's 1000. Sorry, 75. Enter and reset the simulation. If you play it, it's a bit faster and it's result in a good resolution and a good fluid. So when you increase the resolution, it improves the quality of your fluids. The next option we got here is actually time scale. It's actually the speed of your simulation. If you are going for a slow-mo sort of thing, then you can just go play around with this value. For example, if I make it a very higher number like 10, if you play it, okay, so I'm going to set the resolution to 32 again so we can see what is going on. And if you play it, it's very fast. Like it's literally filled this cube with just 15 frames. But if you set it to like a default value of 1, and if you replay it, it's like the default normal motion. But if you decrease the value, it's gonna slow down the motion of the fluid and result in a very slow-mo. As you can see now, it just started. And in 5 seconds, it just reached here. It's not making some it's not making a honey sort of thing, but in fact it's just slowing down the default motion of the fluid. For example, if I set it to 0.8, it's going to result in some sort of slow-mo, and I think 1 is perfect for just the default stuff. And we got a CFL number here. So basically we got a CFL value here. If you increase this value, it will result in a faster simulation. Like it's just a steps, okay, like with sub steps, which is actually like calculating frames. So if you go for a larger number, it will lead to a faster simulation, but not very accurate result. But if you want to have a good looking simulation and a very precise simulation and a very stable simulation, you can decrease this value, but it will cost the baking time, and also the simulation will be very slower to bake, and you will face this problem. But if you want to have an accurate result, you can just make this value very smaller, and yeah, it will result in a good stuff. You got maximum number of simulation steps. It's just a time span of maximum. So basically, if you increase this number, it will take some time to calculate, but it will like make something very stable for you, and it will make the simulation very accurate and very stable on a higher number. So for preview result, you can just go for a default, but if you are looking for a final thing and you want to have a realistic simulation, then you can definitely increase this value and make it better. So if you go ahead, we got a gravity here, delete in obstacle. Just I didn't use it yet. I'm not really gonna talk about it. And basically we got border collision. So for example, I just don't want that the fluid collide with the bottom. I'm gonna turn this off, and if I replay the simulation, it will simply not collide with the bottom, and it will disappear when it reaches the bottom of my domain object. So basically I always turn this on, so I just want to have a perfect simulation. And now we got a liquid here. There are two methods, one is flip and one is epic. What's the difference between those simulation methods? So what's the difference between flip and epic? Well, they're similar to one another, but flip are usually used for product stuff and for very close-up shots because it needs so much details, and like it takes time to bake down, and it's a bit time consuming, and it takes like forever to bake the simulation. But if we, on the other side, if you look at epic, it's just do everything faster, but in fact it's used for a huge simulation, like if you talk about a very huge sort of scene that is not very zoomed in, or you can say very closed up, then you can go for epic simulation, and it will have a very stable sort of behavior. But if you look at flip, flip actually use particle system to move all of those particles. Anyways, flip is used for product, and I think it's better. I always use flip, so just go for it. So we got flip ratio here. So if you're going to like exactly how the flip method work, you can set it to 1. And what I mean by that, like flip method of simulation does make splashes and all other stuff. So if you set it to 1, it will like result in so many splashes and so much detail. So by default it's set to 0.97, which is really good, and it's near to 1, so you don't really need to change it. And we got a system maximum. So here, in fact, system maximum is just particles. If you increase this number, you're increasing the number of particles that are allowed in the simulation. Okay, so for example, if I just make a higher number to something like maybe 10, and I replay this and see what I got here. Well, it's like if it's set to 0, it's using the default system, but if you increase it to something like a higher number, you gotta define the number of how many particles you want in the simulation. So I'm gonna go for 100, and if I replay it, well, I think setting this to 1 is good, because you have to manually increase the value of particles there. As you can see, you can achieve this sort of result with it. And if I replay it again, yeah, I think setting it to 0 is good, because it will just be a default sort of thing. And now we're going to talk about particle radius. So in fact, the particle radius is just defining the size of your simulation. For example, if you want to have if you are having simulation that the volume is very increased and you want to make it very smaller, then what you can do, you can decrease this number. For example, I make it to 0. Maybe something like 0.1, and if I replay this, oh, okay, I think it's very smaller, so I'm gonna go ahead and make it a bit bigger, 0.6, and let's see what we got here. So basically it's resulting in a very compressed sort of simulation that we can do with it. And if I replay it again, like it's getting, for example, if I make it a higher number to something like 5, well, this is what we got here. Now it's not playing because the simulation is not really good. And if I just make it 1.6, and if I replay it again, we have something bigger than before, but setting it to default is good. I'm just explaining every value so you can understand what is going on here, while sampling is actually making the simulation a bit accurate. Okay, so if you want to have an accurate simulation, you can increase the sampling level. What it does, it will increase the number of particles, but it will make the simulation very stable. If I play it now, it will be a bit slower, but it will increase the amount of particles there, and it will make it more of something like very not so much accurate, but it just affects in the number of particles. For example, if I make it a crazy number to something like 10, oh, it's not increasing than 10. Okay, that's fine. I'm gonna set it to 2 again, and now we'll have the default sort of thing. It's faster than before, and we don't have so many particles going on. We got randomness here. So it's just basically randomizing the sampling value. If I make it again to 5 and I increase this number, it will just randomize the sampling. Like for example, if I play it, it will randomize the different areas of your simulation. And I think setting into default value is good, but I'm just explaining you how this works. So I'm gonna hit Control Z and reset everything. Okay, so we got particle maximum. It's actually the number of particle per cell. What I mean by this, like for example, if I just increase this number, it will have more particles per cell, and it will it will result in more accurate results. And if I just increase it extremely, and I will have something looks like. Okay, so let's talk about diffusion here. Well, diffusion is the game changer because it defines the behavior of your fluid. So for example, if I want to make a honey, or I can make a oil, I can make water, I can make anything else that I can think of. How to do it? First of all, you're going to turn on diffusion, and now you have 3 values here. You can play around with different values, but as an example, I'm going to show you how to make a very viscous fluid. So first of all, here is the base value, which is actually viscosity that we had before in Blender. And in the previous version of Blender, we had viscosity, but here we directly have diffusion. And we have the base value, which is actually defining the viscosity of your fluid, how viscous your fluid is. If I increase the value to 10 and make the exponent to 0, and I play it, as you can see, now it's becoming more viscous, more glowed, and it's making the fluid behave like that. Okay, you can have, like, if I increase the exponent value to 10 and I replay it, the fluid is gonna be faster. And if we look at the exponent value, it's actually use how much the viscosity you want here. It's actually multiplying this value into the base, and it defines you what kind of fluid you will create after that. And we got a surface tension here. We're not going to talk about it right now, but if you look at this, it says that surface tension of liquid high will result in greater hydrophobic behavior. So it's actually like for making water stuff, you can just increase this value. The best thing here, we have a preset, so you can choose from those preset. For example, if I go for oil, maybe honey, and as you can see now, this set to 3. If I replay it, it's gonna act like honey, but I think I need more sample resolution to make it more like honey. But you got it. So we got a high viscosity solver. If I turn this option on, and now if I replay it, our fluid will be more viscous and it will behave more like that, as you can see. Yeah, that's how it works. So the next option we got here is particles. Well, this is an interesting part that I really like about Blender. Well, in product stuff, it doesn't really use, but if you took, for example, if I wanna have splashes, I wanna have spray, I wanna have foam, I can do it here. I'm gonna turn on spray, foam. If the camera is inside the liquid, you can turn on bubble because it will create inside. You got different options here, but I'm not gonna go through all of them because they're actually controlling those particles. So I turned those particles on, and I'm not going to talk about them right now because I'm just explaining every option. Once I explain all of them, I will then talk about those options also, and I will let you know how does it works. So for example, if we play, as you can see, now we get something here. These blue dots actually represent the spray and foam on your liquid. So if you play it, now it's very faster, and maybe you can play around with different settings. First of all, let's increase the resolution here. We got view crest potential, we got trapped air potential, we got kinetic energy potential. If I just increase this value to something like that, and if I replay it again and I go into wireframe, I may make it down a bit again so I can see what is going on. It's just making the fluid a bit slower on kinetic energy. If I just make it 20, and as you can see now it's a bit slower, and for example make it something like 62 and I replay it, So as you can see, it's behaving something like that. And yeah, I think I need to explain it to you. How does it works? So like there are different options, you can play around with it. After that, we got mesh here. It's actually just saying it's a mesh. Okay, if I go into wireframe, so I turn off the mesh and I can only see the particles coming down, and this particle actually the fluid, but like it's behaving the same way as the mesh did. But if you turn on the mesh, this particle will be converted into mesh, and the mesh have its own properties. You got the resolution, you got the particle radius, which is the same one as before. We got final and preview, we got different options. Okay, so that's the mesh, and now it's time to talk about some baking settings. Okay, so we got a gravity and all the forces. Well, if you have other forces here, then you can just play around with it. For example, now the fluid is moving down, and I don't want it to move down. If I just make the gravity to 0, now the fluid will not move down, it will stay there forever. But if I make the gravity to 1, the gravity will affect the fluid on 9.8 meter per second, and they will move down like that. If I add another force to it, shift A, I'm gonna add another force, which is actually vortex, and I'm gonna move it upward. I increase the strength to 100, hit enter, and I replay it. Now as you can see, the fluid is behaving the same way as the vortex. So that's how it works. So that's how you can control forces. And if you don't want the fluid to be affected by forces, you can just go ahead to force fill here, and you can play around with different forces value, and you can change them. It's just a viewport display here option in some cases. If you turn on grid display, you can see the resolution of your mesh, and basically it's just showing you how the fluid looks like. If I replay it, it's just showing you a low poly version of your simulation. So basically turn this off, vector display, and now it's showing a different sort of display. And if you play it, as you can see, just a display. Okay, just don't worry about it. So we finally covered all the settings necessary in the fluid simulation. Well, we were left with particles. Like right now, as you can see, the particles moving down, but they're not really making any effect. So first of all, let's go ahead to cache under back. We're going to change the type to all, and we're going to click back all. But before back all, I'm going to set the ending to 120. I'm going to back it all, and now the backing is started, and we will see what we got here. Just wait for this a bit and it will load up. So right now it is backed and it's moving like that. Okay, so shift A, add a mesh and add icosphere. So make this and just decrease one subdivisions and move it to the side. We got icosphere here. So if we select the domain object and go into particle system, we got 3 particle system. First for liquid, leave it. But we got spray and foam, just select the spray and go into render properties. Change the render as to object and just go ahead and select the icosphere. So now as you can see, the icosphere or appear on the surface of the simulation. Right now it's a very low resolution simulation, that is why it's look very low poly. But if you have a huge amount of particle and a huge amount of resolution, you will not notice them, but they will look like a foam, like a spray. So I will increase the randomness of scale and also the scale down a bit, so we don't really see them a lot there. We just barely see them. And now for a foam, we're gonna do the same thing. Object and select the icosphere from here. Now it's also very big, so I'm gonna go ahead and make it to there and make the randomness to a higher number. So if you play it, this is what we got here. So right now it's not really good. Right now I'm going to set the resolution a bit higher so you can see what is going on. I'm going to go ahead and click free all, and I'm going to go ahead and make the resolution a bit higher to 100. Like you can set it to a higher number if your system can control, but right now my system is not capable of doing that. I'm going to change the type to replay so we can see it in the viewport. And what I'm going to do, I'm going to turn off the mesh for now so I don't really see the mesh, but the particles. Turn off the mesh, And now if you play it, it will play smoothly. Well, it's not really smooth. It's very slow, you know what I mean by that. But in fact, you got it. So now it's time to create a very example scene for our simulation. So I'm going to go ahead and hit A, X, delete everything. Okay, so now go ahead and let's create some simple object. I'm going to go ahead to right view. Shift A, I'm going to create a mesh, and it's going to be a cylinder object. I'm going to scale it on the Z-axis. I'm going to move it upward to here, and I'm going to rotate it like that. I'm going to move it. Shift D and move it down to here. And now Shift D and move it. Shift D and move it here. And I can rotate it like that. I can move it a bit and I can rotate it like that. I'm gonna move it slightly to that direction, and I'm gonna go ahead and click Shift D, duplicate it. Okay, so Shift A, sorry, so I'm gonna go ahead to add Shift A. I'm gonna add an icosphere. I'm gonna move it upward like that, and I'm gonna click Shift A and I'm gonna add a cube here. I'm gonna go to scaling tool. I'm gonna scale it up like that. I'm gonna move it upward. I can scale it on x-axis like that, and I can scale it on z-axis also. I'm gonna move it down so everything comes inside the domain object. I'm gonna scale it on x-axis like this, scale it on z-axis, and if you go into x-axis, we can also scale it on y-axis like that. Okay. So select everything and hit Ctrl A and apply the scale so we don't face any problem. I'm going to select the cube and I'm going to go ahead and add a fluid. I'm going to change the type to domain object and I'm going to change the type to liquid. I'm going to select the flow object. I'm going to click fluid. I'm going to change the type to flow and the type to liquid. And the flow type to inflow. Now I'm going to go ahead and select the cylinder, add a fluid, add an effector, and select the other one also, fluid, effector, fluid, effector, and then fluid, effector. Okay, so right now I'm going to select this object here, and I'm going to go ahead, and I think everything's good. I'm going to select the domain object. First of all, I'm going to go ahead and to diffusion, turn diffusion on, and also the high viscosity, because I just want to make something that's similar to a honey. You can see if you play it. So right now we can't really see anything. If you select the domain, this object, it's at the inflow, and if you look at these, it's at liquid. So as you can see, nothing's appear. It's because we're gonna increase the resolution to a higher number. We will be able to see something. I'm gonna set it to 100, and if you go ahead and reset the simulation, we will be able to see a mesh here, but the mesh is very slow to play, and I don't know why is that. But Blender is just a piece of shit in simulation, and it's extremely slow. Okay, so first of all, I'm going to pause the video, and I'm going to go ahead, select the flow object, and I'm going to make it smaller a bit, something like that. Restart, and if I play it, nothing's really happened because we're going to click Ctrl A, apply the scale, and reset the simulation, and again we have it. Okay. So before we play it, I'm gonna go ahead and move it a bit to x-axis, so it falls here, then it flows here, then here, then here, then here. Okay, let's play it again. Okay, let me just reset it and see what we get here. Okay, so nothing works. Let's select the domain object and go ahead and make it 120. Update some settings and reset it again. Let's play it. Okay. It is taking forever, and I don't know why is that. Okay, so now it started baking, like it's very slow. Okay, so first of all, I'm gonna bake it and I will get back to you after the bake is finished. I'm gonna reset it. I'm gonna go to bake, come up to type and change it to all, and I'm gonna set the ending to maybe 120 or something like that, and yeah, I'm gonna bake it and I will get back to you in a few. Okay, so This is what we got after baking the simulation. It's not like really good because it's very slow, and it's because the viscosity is very high. If we look at here, come up to diffusion, we got the viscosity value to 0.05, which is very viscous, and I think we're gonna make it smaller so we can get a very not so huge amount of viscosity there. And yeah, let's do it right away. I'm gonna click free all, and I'm gonna go ahead to viscosity in right here. If I make it smaller to 0.01, maybe, I think it will be better. Yeah. And I'm gonna increase the exponent to 7 a bit, and I'm gonna decrease the particle radius here. Because it's going to compress those particles. And I think now it's time to bake it again and see what we get here. So I click back again, and now it started baking it, and let's see what we get here. I'm gonna pause again and see what we get here. So I noticed something was wrong with the mesh. I think I just made the particles to shrink a lot. So what I'm gonna do, I'm gonna set it to 0.7. I think will be better, and yeah, that's the thing. So now let's go ahead again and click back all, and it will start baking again. I'm gonna pause the video again, and I will see you. Okay, so after baking the simulation, we got this. And now you can change the settings if you want. You can play around with different values if you don't want. And I set the ending frame to 200, and you can just move this object here so it interact with this one and this one a bit here, and rebake it, and it will solve the problem. But I don't want to rebake it. I just want to do some rendering settings. I'm going to go into render. I don't really see anything, so I'm going to change it to cycles. I'm going to set it to GPU compute, and I'm going to make it to denoise. I'm going to go ahead into world setting. I'm going to make it totally black. And shift A, I'm gonna create a camera, and I'm gonna go into camera view. I'm gonna click this lock button, and I'm gonna move it towards here. I'm gonna set it something like that. If I go into output, I'm gonna set the resolution to 1080 by 1920 for Instagram or TikTok, you can say. And if I go into solid, I will first set some camera settings. I'm gonna slightly increase the focal length just a bit, and yeah, okay. So I'm gonna go ahead and click depth of field, and I'm gonna click the cylinder object. Okay, so right now I'm gonna click shift A, and I'm gonna create a plan. It's gonna be scaled up. I'm gonna click this lock to unlock the camera. Or RAW and 90 degree GY. And go into camera view, click G and move it upward, scale it up, something like that. And if you go into render, nothing's happened because we need to add lights into it. So first of all, before adding lights, I'm gonna go ahead and create a new material for these background object. Set the color to something like that, and I'm gonna go ahead and inside, you can say I can play around with different values here. I can change it to from principal BSDF to where is it, translucent. Yeah, set the color to this. Okay, so shift A, I'm gonna create a new light. It's going to be an area light. I'm gonna move it upward like that, and I'm gonna go into solid. I'm gonna go into top view, and I'm gonna click S, and I'm gonna scale it up. So this light is gonna be from the top maybe, and I'm gonna move it upward a bit. If I go into render and increase this power to 100, I think I need to make it 600. I think I'm gonna make it 1500, and yeah, I think that's fine. Okay, so what I'm gonna do in solid mode, I'm gonna go ahead and duplicate this object. Maybe I can decrease it to 600 again. Because I will have more lights there. So I'm gonna go ahead and click double R to rotate, and I'm gonna move it to here by hitting G, and I'm gonna rotate it something like that, maybe. Yeah, I'm gonna move it a bit down, And if I go into render, as you can see, we got something here. If we turn off the overlay, okay, so this is going to be our fluid. Now if I select the fluid, create a new fluid, and if we set it to a color like that and make the roughness down and make the transmission all the way up, as you can see, this is what we got. But we can play around with IOR value. So if I go ahead and search for IOR value for you can say honey, yeah, enter, and now it shows that it's 1.494. let's copy this, and I think it's near to it. If I control V, and we will have the perfect IOR value for the honey. Right now nothing is looking good because the background is all the way black, so I'm gonna go ahead and shift A, and I'm gonna add a light. It's gonna be point light. I'm gonna move it backside the plan, and if I go into camera, I'm gonna move it to center, and if I go into render and make the power to 100, it's gonna change. It's definitely gonna change. If I turn off the overlays and increase these two all the way up, okay, yeah, I think that looks good. Okay, so shift A, I'm gonna create a new light. It's going to be an area light, and I'm gonna go ahead and click G and Y, and I'm gonna move it backward. I'm gonna move it a bit up like that by hitting G. I'm gonna click double R and move it like that. And if I go into render, okay, so first of all, if I come up here, I can hide the icosphere from render and viewport, and if I increase the power to 1000 and I grab it near the simulation, or you can say the fluid, and I hit double R, rotate it, and I'm gonna scale it up like that. I think I'm gonna scale on Z-axis. I think I may need to scale it on X-axis just a bit because I just want one side of it. And hit double R to rotate it. Maybe I can rotate it on that axis. Now the strength is very high. I gotta set it to 500. Enter, and yeah, if I turn this off, okay, that looks good. Maybe we can play around with this light here. I can make it to 3000. Let's see what we get here. Okay, it doesn't change really. Shift D, duplicate it and move it to the other side. Double R to rotate it. I think it doesn't really look good, so I'm gonna go ahead and X and delete. Right now I think if I increase the roughness a bit, and maybe the intensity is very high for this light, I'm gonna set it to 100, and if I just, okay, yeah, that looks good. And now you can render these out. Okay, so let's give some material to these cylinders if you want. Let's set it smooth a bit maybe, and let's select the cylinder object, click new, and let's add new material. Maybe I can make it to, I don't know which color, I just don't know, but I think that looks good. It's material 3. We're gonna select this material for all of them. Just go ahead and select that material, and yeah, you can select, like, now they all have the same material, so if I change from these, it's just changed for every one of them. I can play around with the roughness, and also the transmission. If I increase it to 1, I think it will look good. If I change it to a color like that, and maybe we can play around with different colors. Yeah, that's a color wheel, and I love it. Let's increase a bit, and I think I'll just decrease it just slightly. Maybe we can increase metallic, and I think that's look good. And so guys, that was for today. If you want to get more like that, hit the subscribe button, and thanks for watching, and I will see you in the next one.